Hi everyone. Today I will be studying with you guys the LinkedList in JavaScript. And this LinkedList JavaScript data structure is crucial for the study purposes and for tracking the FANG or MANG like big product based companies. So we generally don't use it in our day-to-day lives. Like I have not used it purposefully, but it is good to have a knowledge so that our minds can open up to more possibilities of a complex problem which comes in future. So keeping this in mind, I thought of studying this today and sharing this video with you guys. Okay, so let's get started. Okay, so what we will be covering in this video will be the introduction to linked list, basic concepts of linked list, node class, linked list class, okay, insert first node, insert last node, insert at an index, get at index, remove at index, clear list, print list, usage example of a complete, and summary and conclusion. Okay, it's I know the contents looks so many, but I will try to cover up. These are small things, but yet very important one. Okay, let's get started. Like introduction to linked list. So I will explain you what is a linked list. Okay, let me just write linked list. So a linked list data structure is a fundamental data structure in computer science. So it is an efficient way of inserting and deleting operations compared to array. No, this is not the right one. Okay, this is not a very good example. Importance. Okay. Linked list ठीक है is a linear data structure. That are important in this because they store and organize data dynamically and flexibly. They are often used when memory is limited or when elements needs to be inserted or deleted frequently. Okay, so it's a kind of a linear when they say data structure, and let me write it down. So second, not this one. Okay. Okay. Let me just create some diagram for you guys. Okay. Hmm. So it is linked list is made up of simple nodes which is having a data and pointer technique, like data and pointer technique. Okay, let me just put pointer before and data. Okay, like that. So what happens is these the new what you say, it is linked to like that. Okay. Hmm. Correct. Okay, it's a somewhat kind of like that. Okay, so pointer first is null because it's not having any parent, that's why we call it as a head node. And tail have a like a tail doesn't have anything after that, so it is saying this will be a tail. Okay, so let me just add it here, pointer data. Okay, like this. So that's how we can increase. If we want to add more, we can add one more node, and it will be added in the linked list like that. Okay, so the rough idea, I know you people might have be getting it now. There are many good examples, and definitions, fancy definitions of it, but that's what I heard of it. Okay. Linear elements are not stored at continuous memory location, meaning like arrays are stored in a continuous memory, but here we have the flexibility so that one place it can be here data there because of the pointers like reference. Okay, are linked using pointers, they say. Okay, now basic concept of the what you say linked list. So they have a node represents each element, so they call this as a node. One complete, this is a node. Okay, it has a head reference to the first node. Okay, so it has a header like a reference to the first node, meaning like a before this. Okay, and it has a tail, last node. Okay, head tail diagram. Okay, okay. I think I have to add one more here. Okay, insert now looks good. Okay, let's see. Okay, so node has a head and tail reference to the first node, tail last node which points to null. Okay, diagram showing with the nodes and the pointers. Okay, this is, I know, like a very basic slide. Now first comes the node class. So in order to create this kind of data, yeah, so first we will have to create this data structure completely. So element block we will create node. Okay, so we will go to YouTube. I'll just add a new folder, linked list. Okay, dot js. This has been created. Let me clear this. Okay, so simple node. Okay. Just 1 second, guys. Okay, we will create a constructor with data and next. Okay, which is equals to null. So in JavaScript you can define a default value in the function like this. Okay, this dot data is equals to data, and this dot next is equals to next. Okay, okay. So various implementations are there. I think they are not using the previous one, they are just using the next. Okay, let me remove this. Okay, this is nothing, just okay. Let me delete. We'll focus first on first node and then we will focus on this. Okay. Now data and next. Okay, same way. Data and next. Okay, so and this mouse pointer will be reversed. Okay, now this is okay. Sorry guys, I like diagram, I also got missed it. So this is a very small data, it is storing the value next points to the next node. Okay, so that's how it is doing it, the class node. This is a very easy example and it should be doable for you guys also. Now comes the linked list part, defining the linked list class, making nodes. Okay, so this is just the previous class was one node. Okay, now we will be creating a linked list that will create more nodes. Okay, head points to the first node, size keeps tracks of the number of nodes. Okay, in code example, let me just create it here. Okay, so like we created a linked list with a like constructor. This dot head is equals to null. This dot size is equals to 0. Okay. Okay. Now different classes inserting our first node. So we will create a method that will like insert the first node. Okay. So let me create a new method. Insert first data, and this dot head is equals to new node, which is our class. Okay, it will go data from this dot head. Okay, so we are inserting the first data here. Okay, that's why like head was null initially. We will add it to a new node and passing the data, and this dot head at this moment it will be null. Okay. Okay, so creating a new node and setting up sets its next to the current head. Okay, update the head node to the new node, increment size. Okay, so what I did is here is let me just increase the size also. Okay, so every time it will be added at the back, like inserting. Okay, now let's just check second, inserting the last node. Okay, so the last node like we will create a method, and let's see, uh, creating a new node. If the list is empty, set it as the head, otherwise iterate to the last node and update it to the next, increment the size by 1. Okay, these are the edge cases and all. So let's create insert last. Okay, and here I will pass the data, because why are we typing like this, because these are the edge cases. Okay, let node equals to new node. Okay, and data is here. Okay, now let current is equals to this. Okay, insert last cases. If not this dot head, if it is not blank, meaning like it's already there, then not meaning if the linked list is blank, then we will give this as a node directly. We will make make this as a node, else part like we will have to iterate. Okay, iterate. Okay, current is equals to this dot head, and what you say, while current dot next. Okay, is not equals to null, meaning like in JavaScript it takes as a not operate like a false value also if it is null or blank. Okay, now what we are doing is we are iterating it to the next one. Okay, like this, so until we have reached it. uh, so once we are in the last, so what we will do, current dot next is equals to node, like this. And once this is done completely, so we will give this dot size plus plus. Okay, this is the insert last operation. Okay, insert first, insert last. Now insert at a particular index. Okay, so if the index is within bounds, like if the index is 0, use insert first, otherwise iterate the node before the specified index, adjust pointers and insert the new node, increment the size. Okay, so let's do it. insert at, we'll create insert at, and like this will take data comma index. Okay, now if we will check like this, index is greater than 0, and index is greater than this dot size. Okay, then return. Okay, so we will not insert anything. Okay, now if index double equals to 0, meaning they want to add it in the starting only, then we will do this dot insert first. We will use directly, okay, data, and that's it. Okay, and then we will just return. Just okay, if it is a genuine case like in between. Okay, so we will create a standalone orphan node here. So we will create let current and previous. Okay, two references of the current and the previous part. So current, let's make it as this dot head. Okay, let me just think. If one counter we will need. Okay, while count is less than index, so we will reach one element before that. Okay, so previous is equals to current. Okay, now we will have to iterate it. Current is equals to current dot next. Okay, and count plus plus we will have to do. So if at the position it will be one before that node, meaning array okay, meaning suppose you wanted to add at the first, second, third. Okay, meaning like third position, so 0 1, so we will have to like come it here 0 1 and 2. Here we want to add one more node. Okay, suppose like this. So what we will have to do, so we will have to reach till here. Okay, that's what we are doing it here. Previous will have the one just before that where we want to add it, and the reason we are doing it, we have to save the reference, like we cannot break the reference here. When I say reference, meaning earlier it was pointing to this, correct? So now what it needs to be done is it needs to be gone to this new node, and this new node should point like this. Like what I'm saying is, now you should like point to this, and this point should come back to this. Now like this we will do the transition. For that only we are just doing. Okay, now once we have reached it, we will have the previous and the current thing. So node dot next is equals to current. So what we are doing is we are building this one connection at this moment. Okay, and previous dot next is equals to node. Okay, like this, and we will increase this dot size. Okay, is equals to this. So is insert check if the index is within the bounds we did. If index is 0, use first, otherwise iterate to the node before the specified index, adjust the pointers and insert the new node, increment the size. So we have done it. Now next method we will have to create is get at index. Okay, so method to retrieve data as a specific index. Iterate through the list until a specific index is reached. Print the data of the node at the specified index. Now comes the, I think, little easier methods. You can also correlate what we will be creating. So get at, okay, and we will pass the index. Okay, now let current equals to head. Okay, let count is equals to 0. Okay, while current, meaning it's already not blank. Okay, so if count double equals to index, then console.log current dot data. That's how, like, we can print. If this is not the case, though, count plus plus. Okay, and current dot next. Else part is like, we are letting it go, and once this is done, so once one second. So get at, I think, we have covered almost everything for this. Remove at index method to remove a node at a specified index. Okay, check if the index is within the bound. If so, at the time of insert specific node is was little tricky. Same thing, if you want to delete this node, we will have to, like, remove the pointer references so that the next chain is not lost. So we will have to remove this arrow and add it here, and remove this arrows. Okay, basically. So what we will do, we will create a separate method like remove at. Okay, so remove at index. If index is greater than 0, and index is greater than dot size. Okay, then return. Okay, now let's create let current equals to this dot head. Okay, let previous, let count, so current, previous, same thing we will have to check, like, okay, this will be simple. This dot header is just, we will put current dot next. Okay, if this is not the case, then while current is equal to, okay, so let me remove space. Okay, else part, like, while count is less than index, then count plus plus, and then previous is equals to current. They are using pointer slow and fast. If you, like, see it in depth, they are doing that. So previous is equals to current dot next. Second, okay. Once we have reached, okay, while it is like this, okay. Once, okay, we have reached, okay, okay, previous dot next is equals to current dot next. We are skipping it directly. Okay, reference, and what we will do, this dot size, make it okay. Okay, So remove at also, like I think decrement the size, adjusting the pointers. Okay, clear list we will do like this. Okay, okay, method to print all the nodes in the linked list. Okay, so it's a good example. One thing I forgot to tell, like in this data structure, linked list always starts from head. You cannot directly jump to here. That's why it's not a kind of a array thing. Okay, you have to iterate one by one to the specific node to reach. That's why. Okay, guys. Now what we will were talking about printing the list method. Okay. So let's see. Okay, let me just print list. Okay, don't need this. Let okay. Current we can be more creative. Okay, let me try if we can work. Okay, okay, like this we can do current dot data. Okay, and current dot text. Okay. Hmm. So enter data of each node using the linked list. Okay, demonstrating the code inserting. Okay, now I think our complete class has been done. So what we will do is we will just try to execute it whether our code is working or not. Okay, writing is okay, you write whatever, but if it doesn't bring the outcome desired, then it's no good. Okay, let me just create a okay, L1, which is linked list, new linked list, initialize the constructor. Now I will use dot insert first. Okay, let me write 200, 300, 400, 500, 600. Okay, something like that. Okay, and let's just insert. Okay, so we will do it L1 dot. Okay, insert it. Okay, so we will do something like 777 on a second place. Okay, no. Okay. So first we will print this. Okay, L1 dot print this. Let's see, I will don't want to do this. Let me save this and run this code. Oh, it's coming in a separate line. So first okay, 600, then 5 4 3 2 1. So we are I think we are adding it from the last. So first node, then on top, then on top, reference way. Okay, you can do it in a arrow reverse way also, it's up to you, but direction should be only in let me sorry my bad. Okay, direction should be in one direction. It cannot be in a simple linked list. Okay, I'll tell you more about it. You must be thinking, why can't we put arrow? So like that. Okay, so like this. Okay, so that's how like 60 it is coming. I want to come into the same list. Okay, then it's no point in it. Let me just run it again. So 6500. Now I will do what? Insert at, and then I will get it print, and I will just comment out because we already know. So okay, So 0 1 2 0 500. Okay, so it added at the third location, not at the second. Okay. Let me add it at the first. 778. Okay, so it is taking index at like, okay, I understood. So some part we can do it like optimize it, but yeah, the main crux is that. Now clear the list, let me just clear it. Okay. Mhm. We didn't implement clear list. Okay, I think okay, sets the head to null and size 0. Sorry, my bad guys, there is one more function I should have added here. Let me just create a clear list. Okay, this function here. Okay, null. Now this looks okay. Let me clear this out. Okay, now let's do this. Okay, so it is printing this, then it's clearing the list, and it will print this. Okay, to know this if it is working, I will just print here. Okay, l1 dot size. Okay. So you know it's 0 and then it is doing it. Okay, so guys, that's all for this kind of a linked list. Okay, we have covered the introduction, basic concept, node class, linked class, insert first, insert last, insert at, get at value, remove at index, clear list, print list, usage examples. Okay, so one thing you might people be curious, why can't we have double arrows? We create one more node like this, and that how we can do. They call it as a doubly linked list, which in the starting I was doing it. Creativity, like that's how other people used to think. Okay, now you can create a doubly linked list like this. Okay, meaning it can go in two directional, bi-directional. That's how a w linked list will works. And if you like be more creative, you can think of now as a tree meaning like I will come to a data structure. It can have a separate branch, it can point to here, then you can have a separate point to there. Okay, that's how you can do it. Then it will be easy for you to map it. So creativity thinking is like there is no limitation. That's why I named this YouTube channel as expanding limits also. But like for the this is for now the link list. Hope you guys enjoyed it. Read more about it. I will say do some questions on link list. Okay, it will help you a lot. Even I will be doing in the some questions related to link list, so that we become more confident, and what we have learned we can implement it. Okay, thanks guys, bye.